Stop for a second, right now. Think about the last time you went for a walk. Were you pushing? Were you moving with purpose, arms swinging, trying to get the heart rate up, trying to feel like you did something? Were you walking the way everyone told you to walk? Some brisk, intentional, get those steps in, keep moving, push through? Because if you were, and most people over 60 are, there is something happening inside your brain during that walk that nobody has warned you about. Something that doesn't show up that day. Something that builds quietly, week after week, until one morning it shows up somewhere you never expected. Not in your legs, not in your lungs, in your memory, in your balance, in your reaction time, in the sharpness you used to take for granted. And the devastating part is this: you thought you were doing everything right. Here is what the research actually says, and it is not what anyone told you at your last checkup. My name is Dr. Adrian Solberg. I am a physician focused on preventive health and senior wellness, and for over 2 decades I have made it my work to get adults over 55 the information that never fits inside a 15-minute appointment. Today I am walking you through 6 specific ways that walking too fast, at the wrong intensity, without the right structure, is working against your brain after 60. And more importantly, exactly what to do instead. Number 3 is going to completely change how you think about your daily walk. And number 5 is the one most people discover only after they have already lost something they cannot get back. Stay with me all the way through. Because this is not about slowing down because you are old. This is about something precise and physiological. And once you understand it, you will never lace up your shoes the same way again. Before we go any further, drop a comment right now and tell me, when you go for a walk, are you pushing yourself to go as fast as you can? Or are you taking it at a comfortable, easy pace? Just type pushing or easy pace. I read every single one, and your answer matters to everything I'm about to explain. Before the list, I need to give you one concept that makes all of this make sense. I call it the threshold trap. Here is what that means. Your brain and your cardiovascular system have a working relationship at moderate sustainable effort, what researchers call Zone 2 intensity, a pace where you can hold a conversation but feel lightly warm. Your body pumps blood to the brain steadily. Your cells produce a protein called BDNF, brain-derived neurotrophic factor, which is essentially fertilizer for brain cells, and your stress hormones stay low. But the moment you push past that threshold into high effort, breathing hard, unable to talk comfortably, heart pounding, everything changes. Cortisol climbs. BDNF production drops. Blood is rerouted toward working muscles and away from higher cortical brain function. And if that elevated cortisol becomes chronic, if it happens every single day because you have been told that harder is always better, it begins to actively damage the hippocampus. That is the part of your brain responsible for memory and spatial navigation. You are not getting more benefit. You are paying a price you cannot see. The threshold trap is the belief that more intensity always means more benefit. After 60, for the brain specifically, that belief is wrong. Keep that in mind as we go through every one of these. Number 1. Walking too fast chronically elevates the one hormone most dangerous to your aging brain. That hormone is cortisol. You have heard of it. Most people associate it with stress. But here is what most people do not know. Sustained physical effort above your personal threshold is interpreted by your body as a physiological stressor, indistinguishable at the hormonal level from psychological stress. When you push your walking pace beyond comfortable day after day, your adrenal glands release cortisol in response to the sustained demand. Once or twice, no lasting harm, but chronically, every morning walk, every afternoon loop around the neighborhood, every day, and that cortisol begins accumulating in tissue, particularly in the hippocampus, which has an unusually high density of cortisol receptors. A 2021 study published in the journal Neurology found that adults over 60 with chronically elevated cortisol levels showed hippocampal volume reduction at rates 3 times faster than those with normal cortisol. 3 times. The hippocampus was literally shrinking, and the most common reported activity in the high cortisol group was daily vigorous exercise without adequate recovery. Think of cortisol like acid rain. A little, occasionally, the forest handles it, But day after day, year after year, without interruption, the roots weaken, the canopy thins, the damage accumulates invisibly until one season the trees do not come back. Here is the cascade. You walk fast every morning to stay healthy. Cortisol rises to meet the demand. Brain-derived neurotrophic factor, the protein that builds new neural connections, drops in response. Hippocampal cells are exposed to high cortisol chronically. Volume decreases. Memory encoding becomes less efficient. You start forgetting words mid-sentence. You walk into a room and forget why. You dismiss it as normal aging. It is not normal aging. It is a specific, measurable, physiological process, and it was triggered by something you were doing to protect yourself. What to do instead? Walk at a pace where you can speak in complete sentences without pausing for breath. Not a stroll, but not a push. If you are breathing too hard to talk, you have crossed the threshold. Slow down. The goal is consistency at moderate intensity, not performance. Number 2, high-effort walking without recovery is starving your brain of the one protein it needs most. That protein is BDNF, brain-derived neurotrophic factor. Think of it as miracle grow for your neurons. It stimulates the growth of new brain cells, strengthens existing neural connections, and protects existing neurons from age-related degradation. It is, without exaggeration, one of the most important molecules for cognitive longevity that your body produces. And here is the key. Moderate aerobic exercise is one of the most powerful triggers for BDNF release. This is why walking is genuinely protective for the brain. This is why the research on daily walking and dementia prevention is so strong. But there is a critical nuance that almost nobody talks about. BDNF production is maximized at moderate intensity and actually suppressed at high intensity. Your body interprets intense sustained exertion as an emergency. In emergency mode, resources go to survival, muscle, oxygen delivery, stress response, not to brain cell maintenance. A 2020 study in the Journal of Applied Physiology measured BDNF levels in adults over 60 after 3 different types of walking sessions: slow, moderate, and fast. Moderate walkers showed BDNF levels 48% higher than baseline after their sessions. Fast walkers, those pushing hard, showed levels only 11% above baseline. Nearly 4 times less brain-building benefit from working harder. You are working harder and getting less of the thing that actually protects your brain. What to do? Your target is a pace that feels genuinely comfortable but present, a light warmth in your muscles, a slight deepening of breath, a pace you could hold for 40 minutes without feeling like you accomplished a workout. That is the sweet spot. That is where your brain gets fed. Type the number 2 in the comments right now if you have been walking fast, specifically because you thought harder meant healthier. I want to know how many of you this has been. Number 3, walking too fast disrupts the one movement pattern your brain uses to map the world. This one is going to stop you completely because it connects to something most people never associate with a walk around the block. Your brain contains a system of cells called grid cells and place cells, discovered by researchers who won the Nobel Prize in Physiology in 2014. These cells are located in the hippocampus and entorhinal cortex, and they do something remarkable. They create a real-time spatial map of everything around you as you move through the world. They track where you are, where you have been, which direction you are facing, how far you have traveled. They are your internal GPS. And this system is activated and strengthened specifically by slow, attentive, exploratory movement, not by fast, goal-driven movement. When you walk fast with your eyes forward and your only goal being to finish the loop, your spatial navigation system is essentially in standby. You are not feeding it. You are not exercising it. You are moving through space without engaging the very brain system that, when it degrades, produces the disorientation and getting lost symptoms that often mark early cognitive decline. A 2022 study in Nature Neuroscience found that slow, exploratory walking with deliberate attention to environment, changes in direction, and surroundings activated hippocampal grid cell networks at significantly higher rates than sustained fast walking on a fixed path. And that regular engagement of this system in adults over 60 was associated with a 34% reduction in spatial memory decline over 3 years. Think of it this way. Your brain's GPS is like any skill. It strengthens with use and weakens without it. Fast, automatic walking on a familiar route is like sitting in the passenger seat of a car every day and thinking you are practicing driving. What to do? Change your route regularly. Walk somewhere new at least twice a week. Look up from the path. Notice buildings, trees, intersections. Make turns you do not usually make. Pause and look around. This is not sightseeing. This is targeted, evidence-based brain training. And it costs nothing. Number 4. The wrong walking pace is wrecking the one thing keeping you upright. This is not about falling. This is about what happens to your balance system long before a fall occurs. Your cerebellum, the part of your brain at the base of the skull, roughly the size of your fist, is responsible for coordination, balance, fine motor control, and the automatic adjustments your body makes with every step you take. Every time your foot hits the ground, your cerebellum is performing thousands of micro-calculations. How to shift weight, how to adjust for surface texture, how to correct for slight imbalances. When you walk at a slow to moderate pace, these calculations happen deliberately and fully. Your cerebellum processes each step completely. The neural pathways for balance and coordination get exercised and reinforced. When you walk fast, something different happens. Your gait becomes automatic. You are not processing each step. You are executing a pattern. The deliberate cerebellar work stops, and the neural pathways that handle novel balance demands. An unexpected curb, a patch of ice, a dog that runs across your path. Those pathways do not get trained. They atrophy quietly. A 2019 study in JAMA Neurology followed adults over 65 for 4 years and found that those who regularly incorporated slow, deliberate walking with attention to gait, surface, and balance showed 41% better scores on cerebellar function tests and had significantly fewer fall-related injuries than those who exclusively walked at high pace. The people who walked fast had better cardiovascular numbers. The people who walked slowly and deliberately had better brains and better balance. Those are not the same thing. What to do? 2 days per week, slow down completely. Walk on varied surfaces. Grass, gravel, gentle incline. Walk heel to toe deliberately on a straight line for 30 steps. Walk for 30 seconds with your eyes closed in a safe open space. These are not exercises. These are cerebellar inputs, and they protect you from the fall that changes everything. Hit the like button right now if you had no idea your walking pace was connected to your balance and your brain at the same time, because this connection is in the research, and almost no one is talking about it. Number 5. Chronic high-effort walking is silently inflaming the one organ that determines how long your brain stays sharp. That organ is your gut. And I know that sounds like a strange turn. Stay with me. The gut-brain axis is one of the most significant discoveries in neuroscience over the past 2 decades. Your gut and your brain are in constant bidirectional communication through a network of nerves, immune signals, and chemical messengers. The health of your gut microbiome, the trillions of bacteria living in your intestinal tract, directly influences brain inflammation, neurotransmitter production, and cognitive function. And here is what almost nobody has told you. Sustained high-intensity exercise, particularly without adequate recovery, increases intestinal permeability. The lining of your gut, which is normally tightly sealed, begins to develop microscopic gaps. Bacteria and inflammatory compounds that should stay inside the gut begin leaking into the bloodstream. Your immune system responds with systemic inflammation. That inflammation crosses the blood-brain barrier. And neuroinflammation, chronic low-grade inflammation inside brain tissue, is now one of the most studied contributors to Alzheimer's disease, Parkinson's disease, and accelerated cognitive aging. A 2021 study in Frontiers in Aging Neuroscience measured gut permeability markers in adults over 60 following different exercise intensities. Those who consistently exercised at high intensity without recovery days showed inflammatory gut markers 52% higher than those who exercised at moderate intensity. And those elevated gut markers correlated directly with lower scores on cognitive processing speed tests. Think of your gut lining like a fine mesh screen on a window. At rest or moderate activity, the mesh holds. Everything that should stay out, stays out. But push that screen under sustained pressure day after day. the mesh stretches, gaps form, things get through that were never supposed to. What to do? Structure your walking week deliberately. 3 to 4 days of moderate walking, comfortable conversational pace, 30 to 45 minutes. 1 to 2 days of intentional slow walking with balance focus. At least one full rest day. And if you have been walking hard every single day for months or years, take 2 weeks at reduced intensity and notice what changes in your energy, your sleep, and your thinking. The results will tell you everything. Type the word brain in the comments right now if this gut-brain connection is something you have never heard connected to how fast you walk. Because this is the research, and this is what 15-minute appointments almost never have time to reach. Number 6. Walking too fast is stealing the one mental state your brain desperately needs every single day and cannot manufacture any other way. There is a specific neurological state that occurs only during slow, rhythmic, low-effort movement. Neuroscientists call it the default mode network activation. Most people know it as the feeling of a mind quietly wandering during a gentle walk, when you are not thinking about anything specific, when ideas float up from nowhere, when you suddenly solve a problem you had not consciously been working on. This is not distraction. This is not wasted time. This is one of the most important cognitive processes your brain performs. Memory consolidation, creative integration, emotional processing, long-term planning. The default mode network is where your brain files, organizes, and makes meaning of everything that has happened to you. It is the mental equivalent of defragmenting a hard drive, and it only runs when you are not pushing. When you walk fast, your brain shifts into executive mode, focused, forward-oriented, monitoring effort and environment. The default mode network goes quiet. The filing does not happen. Day after day of high-effort walking means day after day of your brain never getting to process, consolidate, or restore. A 2023 study in the Proceedings of the National Academy of Sciences found that adults over 60 who incorporated a minimum of 20 minutes of slow, undirected walking, no podcasts, no music, no phone, at least 4 days per week showed measurably better memory consolidation, lower rates of rumination and anxiety, and stronger default mode network connectivity on brain imaging compared to those who only walked at vigorous pace. 20 quiet minutes. That is the intervention, not a supplement, not a prescription. 20 slow, quiet, unstructured minutes, and your brain does the rest. What to do? Designate 2 to 3 of your weekly walks as thinking walks. No phone, no podcast, no destination agenda, slow pace, eyes open and wandering. Let your mind go where it goes. This is the hardest prescription I give people because it feels unproductive. It is the opposite of unproductive. It is the condition under which your brain consolidates everything it has been trying to store. You are not wasting time. You are doing the one thing your brain cannot do any other way. Now, here is your action plan. 6 steps. Start tonight or tomorrow morning. Step 1. Tonight, free. Write down your current walking habit. How fast, how far, how often, how you feel during and after. You need a baseline. You cannot improve what you have not measured. Be honest. This takes 3 minutes. Step 2, tomorrow morning, free. On your next walk, drop your pace until you can speak in full sentences comfortably. Not a stroll, but not a push. Find that window. This is your new moderate intensity baseline, and it is where your brain gets the most benefit. Step 3, this week. Change your route at least twice. Walk somewhere you have not walked before, or take turns you normally skip. Force your hippocampal GPS to engage. This is brain training disguised as a walk. Step 4, this week. Designate one walk as a balance walk. Slow down. Walk on grass or a gentle uneven surface. Walk heel to toe for 30 steps on a flat sidewalk. Pause and stand on one foot for 10 seconds at a stop. These inputs are going to your cerebellum, and they matter enormously. Step 5, starting now, free. Schedule one thinking walk per week with no phone, no music, no agenda. Slow pace, 20 to 30 minutes minimum. This is the walk where your brain consolidates memory and processes what your busy days never give it space to handle. Step 6, this week, one sentence to your doctor. Bring this to your next appointment. I've read that sustained high-intensity daily walking without recovery can chronically elevate cortisol and suppress BDNF in adults over 60. Can we talk about structuring my exercise to optimize brain health specifically? That sentence will start a conversation your doctor will respect and almost never initiates. And please, see your doctor promptly if you notice any of the following during or after walks: chest pain or pressure, sudden dizziness or loss of balance, unusual shortness of breath at any pace, a fall or near fall, sudden vision changes, or any new confusion or disorientation after exercise. These need attention quickly. Do not walk through them. Here is the bottom line. Walking is one of the most powerful things a human being over 60 can do for their brain. The research is overwhelming and consistent, but the pace, the structure, and the intention behind that walk determine whether you are building your brain or quietly taxing it. Harder is not always better. After 60 for the brain specifically, the sweet spot is moderate, varied, deliberate, and quiet. Not aggressive. You are not just aging. You are dealing with specific, identifiable, addressable physiology, and you deserve to know that. I have a video coming very soon on exactly how the timing of your daily walk, morning versus afternoon versus evening, connects to cortisol rhythm, sleep quality, and long-term memory protection. The research on this is fascinating and almost completely unknown outside specialist circles. That is a conversation you will not want to miss. If today gave you something you did not have this morning, subscribe and share this with one person over 60 who laces up every day and pushes hard because they think that is what protecting their brain looks like. You might change what happens to them. And before you go, leave me a comment with this. Are you going to change anything about how you walk after watching this? I want to know. I read every comment, and your answers shape exactly what I make next. I'm Dr. Adrian Solberg. I'll see you in the next.